Okay, we're given a triangle, ABC, where the length of AB is 5, and BE is divided into segments where BE is 1, EF is 3, FC is 2. There's a circumcircle that circumscribes that triangle. And if we consider ray AE meeting the circumcircle at G, and AF extended meeting the circumcircle at H, and that GH is parallel to EF, we're supposed to come up with a length for AC in a certain form. Okay, and it looks like AC we could find by the law of cosines if we could find this angle right here, angle beta, and that's what all the work is involved in. We should note that triangle AEF is similar to AGH by angle because we got these two parallel lines cut by transversal FH. So these corresponding angles are congruent, and angle A is included in both triangles. So by angle, we've got this proportion has to be true. And then we're going to use the theorem about two chords intersecting inside a circle. Point where they intersect divides those chords into two segments whose products are equal for each chord. So for point E, BE, which is 1, times the other part of the chord, which is EC, is equal to the product of the segments of chord AG, which is AE times EG. But this we know, BE times EC, 1 times 5 is 5. So this is what's true. And then we're going to try to replace this EG with, well, it's the entire segment from A to G, take away AE. So they're segment addition postulate. So I can replace EG with this, and then if I solve for AG by dividing by AE and then adding AE to both sides, this is an expression for AG. If you do the same thing for point F, you get this expression for AH, the entire segment. Why did we do that? Because we want to get a relationship between AE and AF. And we're going to use this ratio, or this proportion, I should say, from the similar triangles. AE is to AG. Well, where did I get this? From right here. As AF is to AH, where did I get this? From right here. Okay. And if I multiply this numerator by the reciprocal of the denominator on both sides, I get this proportion. If I cross multiply, I'll notice that these two terms cancel out, and this is the relationship between AE and AF. We're going to note that on board 2. There it is, AE squared, 8 AE squared equals 5 AF squared. Now, if we use the law of cosines for triangle ABE, we can get an expression for AE squared in terms of beta. AE squared equals 26 minus 10 cosine beta. And for triangle ABF, it's the same idea, 5 squared plus 4 squared, etc. So now I've got two equations involving cosine of beta, but I've also got this relationship, 8 AE squared equals 5 AF squared. So 8 times, what is this? That's AE squared equals 5 times, that's AF squared. And now I've got an equation where I can actually solve for beta. Okay, and I won't go through the steps. We could actually find angle beta, but we don't need to because we're going to use this relationship right here, that AC squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of beta. That's from board 1. But we now know the cosine of beta is negative 1/40th. So AC is the square root of 61 minus 60 times the cosine of beta, negative 1/40th. If you combine, you get a common denominator and add those fractions, you get square root of 125 halves. I can take the square root of the 25 and get the 5 outside. There it is. A is 5, C is 2. Add the A and the C, and you get 7. Okay, there you go. If that helped, if you have any questions, post a comment.